Chapter 5.2, Day 2, Simplify Radicals. Properties of rational exponents and radicals. In previous lesson, we discussed the rational exponents, and now we are going to discuss the radicals. So we are going to do the example number 3, writing radicals in simplest form. So let's discuss letter A, square root of 24. So we are going to write this into a simplest form if we can. We start with making prime factors for 24. So we are going to see what are the prime factors for 24, and I'm going to use a factor tree for that. And here I got 2 times 2 times 2 times 3. So these are the end numbers and they are prime factors for 24. Now, in order to get out of the radical symbol, we need to have a pair of a same number. So each pair comes out as a single number. So we see that here 2 and 2 makes a pair. There are no other pair that we can take it out, so just one pair, 2 times 2. And take out one number from each pair outside of the radical symbol, and inside you're left with the remaining number, that is 2 times 3. So for this type, your answer should be 2 square root 6. For letter B, we are going to find the cube root of 135 and write it into a simplest form. In this case, we need to have same number 3 times. So there should be a same number with multiply with each other at least 3 times to get out of the radical symbol. I'm going to do the same step, that I'm going to make a factor tree for that. So that's going to be 5 times 27, and that's 9 times 3, and 9 is further divided into 3 times 3. So the end numbers are 5, 3, 3, and 3. You can see that these 3 are multiplied with each other 3 times. So when we write it back inside the cube root, we write it as 3 times 3 times 3 times 5. Since they make group of 3 and we are finding the cube root, so this one of the 3 from each group comes out. So this 3 comes out, and inside you're left with cube root of 5. So the 3 times cube root of 5 is your answer. Letter C is very easy. 1000 can be easily written as 10 times 10 times 10. They make a group of 3. One number from each group comes out, so that cube root of 1000 is 10. And you don't have to write cube root of 1 because you left 1 inside. You don't have to write this. You just can write 10 is your answer. Cube root of 1000 is just 10. Next is letter D. We are going to make a factor tree again for this one. So 162, and that's 81 times 2. And 81 can be written as 9 times 9. And that's 3 times 3 times 3. So the prime factors for this one are, there are 4 3s and 1 2. You can write it back inside the cube root. So for cube root, you need at least 3 numbers to get out of the radical symbol. So we have 1 2 3 4 3s and 1 2, but we are going to make group of 3, and we are going to take out the negative and a 3, and inside you're left with 3 cube root of 3 6. So let's take actually the this negative into positive, turn that negative into positive. That would be easier. So we just write 3 cube root of 6, and that's going to be your answer. So just turn that negative into positive. Now let me remind you the list we have created in the past. We said that 4 to the power of 4 is 256, and that really helps me to find the fourth root of 256 is actually 4. So again, that we listed that 4 to the power 4 is 256. It means fourth root of 256 is 4. So we just write that either that's going to be 4 times 4 times 4 times 4. They make a group of 4. So take it out of the radical symbol. So the fourth root of 256 is 4. Again, this is also we have done that negative 6 cube is negative 216. So you can write this as negative 6 times negative 6 times negative 6. They make a group of 3, so they take it out of the radical symbol. So cube root of negative 216 should be a negative number, so that is going to be a negative 6. So next is, you can see that example number 6, simplifying variable expressions. In this case, unlike a previous example, you have a variable as well. And the way of doing this is still the same. So you're going to find the prime factors for letter A, and then you're going to make a pair and take out one number from each pair. So the prime factors are 49 times 2, and that's 7 times 7 times 2. Now the only pair we got is just 7 times 7. So number from each pair outside, you're left with 2k inside. So 7 square root 2k would be your answer. In this case, the next one, you're going to find the factors for 64. So that's 4 times 4 times 4. Or we should already know from the list that the 4 cube is 64. It means the cube root of 64 is just 4. You can write the y times y times y times y. For y to the power 6, you're going to break it down like that. Now you need to make a group of 3 to get out of the radical symbol. And you're going to take one number from each group outside of the radical symbol. So you have 4 outside, one of the y outside, and one of the y outside. Inside you're left with nothing or just 1. So your answer is 4y square. For letter C, if you find the prime factors for 128, they're going to be 2 times 2 times 2 times 2 times 2. It's like 7 times 2. So 2 times 2 times 2 times 2 times 2 times 2 and times 2. So we can count it as 1, 2, 3, 4, 5, 6, 7. So you can break this down, and that's going to be these many 2's when you break it down. And you're going to have n to the power 4 times n to the power 4. They need to make a group of 4 to get out of the radical symbol. One number out from each group, so that's 2. And these 2 would stay inside, unfortunately, because they don't make a group of 4. N to the 4 cancel with 1 over 4, so that's 1n outside. Again, this n to the 4 is cancel with this 4, so there is 1n outside, and there is 2 times 2 times 2 stay inside. So your final answer is 2n square, fourth root of 8. Next you're going to do question letter D, and you're going to break this down again. So the prime factors are going to be, let's say, 2 times 2 times 8 times 7, and r times r times r times r times r times r. So 1 2 3 4 5 6, there is one more, and you're going to break this 2 times 2 times 2 times 2 times 2 times 7, and there are 1 2 3 4 5 6 7 r's. You're going to make a group of 5 in order to get out of the radical. So 1 2 3 4 5, one of them comes out. 1 2 3 4 5, one number from each group comes out, and inside you're left with fifth root of 7 times r, and that's going to be 2r fifth root of 7r square. For letter E, you're going to find out the cube root of 24m cube. So you're going to factor the 24 in a prime factor. So that's going to be 2 times 2 times 2 times 3 and m to the third. This make a group of 3, so one of the two outside. And m to the third means that there is a power 3 which can cancel 1 over 3. So 1 over 3 cancel with 3. So what you have inside is 3 and m outside. So the answer is 2m cube root of 3, because the cube and cube root cancel each other, so just the m outside. Now for letter F, you can do it with two ways. So you got here is 3 times 3 times 3, that is 27. X to the third, x to the third, and x to the third. One number from each group outside, and here 3 and this 3 cancel, so just x outside, 3 and 3 cancel, just x outside, 3 and 3 cancel, just x outside. So 3x cube is your answer. Or you can look at in this way, that 27x to the power 9 is 1 over 3 on the top. So on the top 1 over 3 mean cube root. You can write it in a radical form, or you can write it in an exponent form, and then you can separate them. 27 cube root and x to the power 9 cube root. Cube root of 27, as we know, is 3, and 9 divided by 3 is 3, so x to the power 3. So 3x to the power 3 is your answer. Next is example number 7, and right now we have a fifth root of 4a to the power 8, b to the power 14, and c to the power 5. Just remember one thing, if you have a 1 over 5, you need a 5 to induce 1 over 5. If it's a number, you need a group of 5 numbers to get out of the radical symbol, or you need a exponent 5. Let's see how I'm going to break this in the form that I get the power a to the power 5. So I'm going to break this as a to the power 5 times a to the power 3. So a to the power 5 times a to the power 3. That gives me total of 8. But I need 5 in order to cancel 5. Next, I'm going to break b to the power 14. So I'm going to break this as b to the power 5 times b to the power 5 times b to the power 4. So that makes it 5 plus 5 plus 4, that is 14. And the next one I don't have to break it because it's already c to the power 5. This number obviously is just 2 times 2 and not make a group of 5. So it stay inside. The letter a to the power 5, this 5 and this 5 cancel. So the 5, just 1a outside. This 5 and this 5 cancel. So 1b outside. This 5 and this 5 cancel, the another b outside. And lastly you have c to the power 5. So 5 and 1 over 5 cancel, so c is outside. Now what is left inside? So left inside is that number 4, a to the power 3 and b to the power 4. So outside number would be a b square c, and inside would be 5th root of 4a cubed times b to the power 4, and that's going to be your final answer. Next we are going to do the cube root of 16a cubed b to the power 8. Now in this case we need for numbers we need at least a group of 3 to get out of the radical symbol. We can break the 16 down as 2 times 2 times 2 times 2. And to the power we need at least a power of 3 so that we can cancel the 3 with 1 over 3. So here I have b to the power 3, b to the power 3, b to the power 2. So you can see that 3 plus 3 plus 2 is 8. So we can break that down as this. This make a group of 3. So 1, 2 outside from each group. This 3 and 3 cancel. 3 and 1 over 3 cancel. So 1 of the a outside. 3 and 1 over 3 cancel. So 1 of the b outside. 3 and 1 over 3 cancel. So 1 of the other b outside. Inside you left with the 2 and b square. So 2b square. Answer is 2ab square. Cube root of 2b square. Next is letter C. You're going to find the cube root of 56 x to the power 5 times y. I'm going to break this down as 8 times 7 x to the power 3 times x to the power 2 times y. Cube root of 8 is 2 outside. You're left with 7 inside. 3 and 1 over 3 cancel, so x outside. You're left with x square inside and y as well. So the answer is 2x cube root of 7x squared y. For number letter D, you're going to make a factor tree if possible for 405. And that's going to be 81 times 5, and that is 9 times 9, and it's 3 times 3 times 3. So 3 times 3 times 3 times 3 and 5. So you're going to have 4 of the 3 times 5, x to the power 3, y to the power 2. They make a group of 4, so one of the number outside from each group. Inside you're left with 5 x cube y square. Now none of the letter comes out because none of the letter has the power bigger than 4 or bigger than 4. If you have a power 4, only then you can cancel 1 over 4. So for example, if you have 4, you could cancel 4 and 1 over 4. If you have more than 4, like 5, you can break it down as 4 and 1. But these are the power that are less than 4, so we cannot do anything. We'll have to leave them inside. Question number letter E, and we are going to break this down to find the cube root if possible. So this number 40 is little easy. You can just write it down as 8 times 5 because we know the cube root of 8 is 2. So we can break 40 as 8 times 5. For A, I'm going to break it down as A to the third, A to the 1, B to the third, B to the third, and B to the second. Cube root of 8 is 2, that's outside. Cube root of A cube is A. Cube root of B cube is B. Another B, and what you left inside is the numbers 5A and B square. 5A and B square. So the final answer is 2AB square, cube root of 5AB square. For letter F, you can break this down as 64 times 2 and x to the power as 4 and 3. Similarly for y, 4 and 3. Now I'm going to break the 64 down, and how many 2's it goes in 64? We can see that 2 times 2 is 4, times 2 is 8. 8 times 2 is 16, and 16 times 2 is 32. 32 times 2 is 64, and then another 2. And then you have x to the power 4, x to the power 3, y to the power 4, y to the power 3. This makes a 4, group of 4. One of the number comes out. 4 and 1 over 4 cancel. One of the x comes out. 4 and 1 over 4 cancel. One of the y comes out. Inside you're left with is 4th root of 2 times 2 times 2. X to the power 3. Y to the power 3. So the final answer is 2xy, 4th root of 8x cube y cube.